The next thing that we're going to try and tackle is so we're going to do a lot of graphing over the next couple of weeks. And the next thing that we're going to try and tackle, as far as that goes, is um, we're going to be talking a lot about graphing. Um, we're going to be talking a lot about graphing functions specifically, and we're going to end up talking about uh, how the graphs of different um, functions that you're being introduced to in Algebra 2, um, how they're supposed to look. So the first thing that I want to remind you about from geometry class is rigid transformations. Okay, so let's say that we have a um, let's say that we have something that looks like this, a triangle, right? And what we learned about in geometry class is that, as a matter of fact, I guess I should probably, well, no, I'm going to keep this black. What we learned about in geometry class is that you can take something like this and you can transform it according to certain rules, right? So the first kind of transformation that you would have learned about, and certainly the first one that we're going to be dealing with in Algebra 2, is something called translation. Translation. And I know what you're saying. I know what you're thinking. You're thinking in your head, Mr. Letts, when you translate, you're actually you what you're probably doing is like talking to somebody in another language. So say there's a student who speaks mostly Spanish or something like that, and you're trying to translate a lesson from English into Spanish. Yes, that is one use of the word, but in math, what it means is you're going to take something and you're going to move it, but the thing that you are moving is going to the new version of the thing that you move is going to stay congruent to the original shape. Okay, so what we call the image will be congruent to the original shape. And that's important. What it basically means, what it's basically saying is that it's as if you're taking this and it really existed as a real triangle in the real world, and you were able to pick it up with your hands and say, I don't know, move it over that way. Okay? In which case you would be translating it to the right by moving it. So let's go ahead and let's give that a try. Let's say we were going to take this and we were going to move it over this direction. Okay? Your image, which is the thing that I'm drawing in blue now, is going to be congruent, and I'm trying to make this as congruent as I possibly can. So it's going to be the same exact shape as your original shape, as your pre-image. Okay, it's just going to be moved over. Okay, and let's just say we had some. Let's just say we had some markers here, right? We could even talk about mathematically how far we moved this sucker, right? Okay? So what we would say is you can see, since I put them in there, that we could say that we moved this thing over 1, 2, 3, 4, 5 units. So we translated this. It's a translation 5 units to the right. Okay, 5 units to the right. This is a translation 5 units to the right. And it means that every single point, this point has moved over 5 units. 1, 2, 3, 4, 5. Right? This unit has moved over 5 units. 1, 2, 3, 4, 5. And this point here has moved over 5 units. 1, 2, 3, and we'll just say this is 4, and this is 5. Okay? So each of those points has moved to the right. 5. Did I say inches? I meant units. I hope I said units. Anyway, so that's how translation works. Okay, now that's how translation works with something in what's called a rigid a rigid object in geometry. Now let's figure out what it would mean, what it would look like to us here in Algebra 2, right? So once again, I'm going to make myself a little graph here. I'm using my phone as a straight edge, okay? So that's why you get some bumps. I guess I should have put a different side instead of the side that had the volume buttons, huh? And that was cute. All right, here we go. Let's do a little surgery on this. Anyway, okay. All right, so there we go. So then, let's say that we had something like a parabola. And this time I'm going to go ahead and do my units to start out with. Okay, let's say that we had a little parabola. And let's say that my parabola started here. Okay. Okay, and now it looks like a little face. Okay. All right. And so my parabola kind of looks like this U shape, right? Okay. And that's what they look like. You know, that's exactly what a parabola looks like. That is a quadratic equation, right? So we can do a transformation. We can translate, okay, this parabola, okay, which is a quadratic, which represents a quadratic equation. We're going to translate this parabola, let's say, I don't know, 3 units to the right. Okay, so what I'm going to do is I'm going to get my lightning yellow, and I'm going to go 1, 2, 3, okay, with that point. And I'm going to take my lightning yellow, and I'm going to do 1, 2, 3 with that point, okay, and that's going to go here. And then I'm going to take my lightning yellow, and I'm going to do 1, 2, 3, and I'm going to end up right here on the y-axis. And it's going to happen with this guy and this guy too, okay? So I'm going to have one over here and one, let's say, over here. And so my new parabola, and that's exactly what a parabola looks like. My new parabola, everything is going to be moved over to the right 3 units. And that's how translation works when you're talking about the graph of a function.